Evaluate two-sided limits analytically for rational functions with removable discontinuities through expansion. Alright, so in this lesson we're going to learn how to evaluate limits of rational functions through a method known as expansion. And this is a method you folks have already used in previous math classes. It's just a specific technique that's also applied to limits. So let's take a look at how it works. So in our first example, we're going to look at the limit as x approaches 0 of x over 1 minus the quantity of x minus 1 squared. So as we previously learned, the first thing we always want to try is direct substitution, because maybe the function we're taking the limit of is continuous. And if it's not, it usually gives us some hints of what to do next. So we will try direct substitution first in this example. So that means I'm going to substitute in 0 for all the x values. So I'm going to get 0 over 1 minus 0 minus 1 squared, which is going to be 0 over 1 minus negative 1 squared, which will be 0 over 1 minus 1, which ends up being 0 over 0. So as we had previously learned, 0 over 0 is not bad news. 0 over 0 just means that we now know that we have to factor out and cancel. So we're going to factor and cancel. So going back to the original limit, we have the limit as x approaches 0 of x over 1 minus x minus 1 squared. But here's where the issue comes into play. In the form that it's in, there is nothing we can really factor. So if we can't factor, how are we expected to cancel? And that's where the expansion part comes in, because we do have this expression, the quantity x minus 1 squared, that if we expand out, that might allow us to then factor something out and cancel. So that's what we're going to do. We're going to expand this. So I get the limit as x approaches 0 of x over 1 minus x minus 1 times x minus 1, because that's what squared means. A lot of students like to fall into the trap where we would just go, oh, x minus 1 squared is equal to x squared minus 1 squared, which is 100% completely wrong. That's not how squaring works. Squaring says we take the base and we multiply it by the base however many times the exponent says. So that's what we're going to do here, and that's going to require us to FOIL. And then when we FOIL and simplify, we're going to get the limit as x approaches 0 of x over 1 minus the quantity x squared minus 2x plus 1. Now again, I did skip some steps in here, but if you would like to be foiled out, please just come and ask me. I'm more than happy to help. Alright, so next up, we do need to take this negative sign and distribute it to all the terms. So we're going to get the limit as x approaches 0 of x over 1 minus x squared plus 2x minus 1. And then from here, we can see the positive 1 and the negative 1 are going to cancel each other out, leaving us with the limit as x approaches 0 of x over negative x squared plus 2x. So now that we've expanded this, we've been able to simplify the expression through the expansion. Now we can factor and cancel. So unfortunately, the numerator is just x, so there's nothing we can cancel there. However, the denominator we can factor an x out, leaving us with negative x plus 2 on the inside. And now we can see we have a common factor of x in the numerator, a common factor of x in the denominator. And when we cancel those out, we're going to get the limit as x approaches 0 of 1 over negative x plus 2. We can try direct substitution again, giving us 1 over negative 0 plus 2, or a final answer of 1/2. So these types of questions are very similar to our normal factor and cancel routine, except there's that one added step of expansion before we are able to factor and cancel. Let's take a look at one more to make sure that we really understand what's going on here. So we have the limit as h approaches 0 of the quantity 1 plus h quantity squared minus 1 over h. And just like before, we always want to try direct substitution first. 1, because it's simple, and 2, we might luck out and get a continuous function, or 3, it might give us a hint as to what direction we need to move into next. So let's see, h is going to be 0, so we're going to get 1 plus 0 squared minus 1 over 0. And already I know this is bad news because we start out with 0 on the bottom, but let's make sure we actually get 0 over 0 as opposed to a number over 0. Because a number over 0 is different, and we'll address that in future lessons. But now we just want 0 over 0. So let's see, 1 plus 0 is 1, so we're going to have 1 squared minus 1 over 0, giving us 1 minus 1 over 0, and then we get our 0 over 0. Which again is good, because we know that we need to factor and cancel. But, as we learned from the previous example, we have to expand the expandable part first. So, we'll start off with the original limit as h approaches 0. H plus 1 squared, remember, is 1 plus h times 1 plus h. Please do not square the individual pieces, that is incorrect. And then we'll FOIL the 1 plus h times the 1 plus h to get 1 plus 2h plus h squared after we do some behind-the-scenes simplification, and then minus 1 all over h. Well, we can see the positive 1 and the negative 1 will cancel each other out, and that's going to leave us with the limit as h approaches 0 of 2h plus h squared over h. And that looks like something we can factor, so we'll go ahead and do that. In the numerator, we can see that both terms have an h, so we can factor that out. The denominator just has an h in it, so there's no factoring we can do there. But now we have a factor in the numerator and a factor in the denominator that are the same, so those can go away, leaving us with the limit as h approaches 0 of 2 plus h. And then we can do direct substitution to get 2 plus 0, giving us an intended height of 2. And that is it, ladies and gentlemen, nothing more. Here it's basically just direct substitution, seeing if we get a number, or 0 over 0. If we do, expand, factor, simplify, answer.